Hello friends, my name is Gopesh and I welcome all of you to my YouTube channel Grow by Growing Others. So friends, today I am going to explain quicksort algorithm. This is one of the important and little bit tricky algorithm in sorting. So stay with me, follow my instructions and just pay attention. I will try to explain in a very easy words and will make it so simple for you so that you will understand the problem, you will understand the algorithm, you will also understand, and once you understand the algorithm, you will be able to write the code because once you understand the algorithm, you if you have clear visibility, clear understanding of the algo, then you can frame, you can draft the code, and there you won't be stuck. So let's start and we'll discuss what is quicksort and what are different approach to implement quicksort and what is the base mechanism to implement quicksort. So guys, just note down, quicksort is implemented implemented using divide and conquer methodology. Divide and conquer methodology. These are the terms that is with respect to data structure, data structures. So I hope you are aware with basic data structure concepts and fundamentals. If not, I will bring videos on the fundamentals and will cover there what is divide and conquer. But once you understand this problem and algorithm, you will be able to understand what divide and conquer does. Okay. All right. So let's start and I will tell you how we can sort quick sort these elements in the given list. Okay. All right. So there are two approaches. Oh, One is called one is called Ho array. Ho array. I don't know how to pronounce it, but this is what the spelling is. Ho array partition. Ho array partition. These are the approach. And another is Lumoto. Lumoto partition. Guys, these like algo are given by famous scientist from British British scientist Ho array. And I will tell you why we are calling it partition. So, this is the approach. Partition is indicating the approach. So, basically, Hore was a British scientist who gave this, who originally given the algorithm of quicksort. And why we are calling partition, I will tell you. So, today we'll discuss Hore partition, meaning we will gonna use Hore partition approach to develop to understand the quick sort algorithm, and then we will implement that. For now, we will skip Lumoto partition because I mean I think if we just know one, it would be enough. And later, at some point in future, I will create video on Lumoto partition approach as well. Okay. So what I am calling, why basically it is called partition. So guys, this is your given element, right? So if you just do one thing, just you do one thing here. If you take this element 11, right? If you place this element at index, if we go left side, all elements will be smaller. And if we go right side from the placed element, then all are like greater. For example, if this is what we have, right? Like right now. So if I take, so follow with me. Like if, for example, we have 11, we have a 9, we have then 29, right? So if let's say, and then if we like go from here go from this side. Like if we start from the left side and keep on going, and this is like our right, right? So here I can say like right. What I'm saying is, what I'm saying is, so 11 is your leftmost, 28 is your rightmost. So what I'm saying, you keep on going, you keep on going, and where you find element greater than 11, and you can start with like 11 itself. So left and right. So just start with 11th first element, and you pick, I mean, you keep on going, and stop where you find number greater than 29. So you will go, and 29 is a number which is greater than 11. So you just stop here. Okay. Now from the right side, you keep on going left, and you have to stop when you find number less than 11. So basically what you are doing, you are starting from leftmost, and you are keep on going, and as when you find a number greater than 11, because 11 is our start, like 11 is, we have like made 11 as our start point, right? So you have to keep going your right side from leftmost, and as when you find 29, then you stop, then you stop. And similar, you start also start from right side. So yeah, as when you stop, when you start your travel from left, and when you find the number greater than the start number, you just stop. Now you keep on going from right side. So you have to keep also going on from right side, but as when you find number less than 11, then you have to stop. So if you have observed what I'm saying, this was your start left stop here. Sorry. Maybe I can draw this Excel, and okay, let me write this in Excel. Okay. Then I think that would be more clear what I'm trying to say. Okay. So let me bring this text to column. Here I will say delimited, delimited with comma. Here I can say comma, and you will be getting this one. All right. So these are the numbers. These are the numbers. Stay with me, guys. Pay attention. Just show some interest. You will be able to understand it. You will be able to crack this. Okay. So this is what the list you have been given. Let me color it. Let me color it. Okay. Now what I was saying, so this is my leftmost. Okay. Leftmost, or let me call it a start index. This is, I can call, so this is my start index. I will color it, and let me copy it. And this is my end index. Agree? This is my end index. So here I will call it end index. So three things we would need: end index. And you just think of index in terms of index. So start is your start index, and the last one is your end index. Right now, I can go and pick one element, and in my case, I will pick the start. In your case, also, in every case, the recommendation is you pick whatever number you find at zeroth index, at a start index, for example, 11, right? You call this 11 as a pivot index. Pivot index. Start index is fine. So here you just call it pivot index also. Pivot index. So here I will say it pivot index. So guys, just a small correction. So guys, I hope all good. Like we have now three indexes, and let me color it different so I can maybe can it mark it green. So you have to get a start index, which is very starting point leftmost, which is zeroth index. You call it start index. The last one, you call it end index. And also you have to declare one pivot index, and pivot index and start index initially will be pointing to same element, and that is a start element. Okay. Now what? For a Partition's approach says, what it says, you take your start index from leftmost and keep on going right. Like currently it's what? 11. Then you keep on going, then you can go to 9. And as when you find element which is greater than start, which is greater than pivot index. So just to make it easy, you can start index just after the pivot index. Just a small change, guys, just a small correction. What I'm saying is your start index, like the very first index, the zeroth index, is a pivot index, and one index is a start index, and last one is a end index. Okay. So what I am saying here is, as per the Hore partition approach, it says you just take pivot index and which is 11 right now, and start comparing with your start index. So you see, right, like your start index 11 is start index, what it is like 9. So you have to basically keep on going until you find the number which is greater than your pivot number, greater than your pivot number. When guys, one another thing, when I say index, you just think as a index. Sometime I am mixing index and element. So if I say pivot index, just think of a element 11, not as a index like 0, 1, 2, 3 like that. So first thing that you have to note down is you have to keep moving your pivot, you have to keep moving your start index. Like this is your start index currently set at 9. You have to keep moving your start index until you find a number which is greater than the pivot number. Pivot number is 11, and if you see here, 29 is a greater than 11 pivot number, right? So you have to keep on moving. So finally what will happen? You will end up your start index at 29, because this is where you have to stop, right? Stop. You came here and you stopped. And as when you find the number greater than pivot number, you stop iterating. You stop iterating the start index. Now you go and start moving the end index. As when you find your number greater than pivot number, you stop the iteration of start index and you shift it to end index. Now the iteration or move for end index is opposite, exactly opposite as start index. Now here you have to keep on going from rightmost to left side, and you have to go until you find a number lesser than pivot number. So what is our pivot number? Currently 11. So for start index, we were seeing the greater than pivot number, but when we move the end index, we see the less number than the pivot number. So we taken our journey from here and we went here. So 15 is great. So 28 itself is greater than 11. 15 is itself greater than 11. And 2 is something which is less than 11. So your start index came here. Now, as when you find these two conditions matching, like start index is number greater than pivot index, end index number is less than pivot index, you just swap these two out. I- Basically, you swap 29 with 2, meaning let me copy these two and again copy this same thing. So as when you find these two conditions met, you have to swap the numbers. So you just copy 2 here, 29 here. Now your end index is currently at 29. Agree? Now you keep on going with the same formula, same formula. So what do you see? Now you see that your start index is at 2. So 2 is less than 11. So you have to keep on going. 7 is less than 11. You have to keep on going. Now you will reach to 29. Again, 29 is greater than 11. So your start index will come here, will come here. Let me hover over it, right? Now say 29 again you found and it's greater than 11. You stopped your iteration for the start index. Now you will take your end index and start moving from right to left. And when you have to stop, when you find number less than 11. So the next, just next number 7 is less than 11. So your start index will come here finally, and you will be stop here, right? You will be stop here. So now you must be thinking, so first condition was when you keep on iterating and find number greater than your pivot number, you stop at it, start index, and similar you move the your end index and keep on going until you find a number less than the pivot number. When you meet this condition, you swap those numbers. This was the first condition. Another condition is when you cross, when end index crosses the start index, when you cross the, when end index is crossing the start index, that point you swap your end index with the pivot index. So what will happen now? So let me copy again. Now what is the condition? So second condition, if your end index is crossing the start index, then at that point you take your end index number and swap with the pivot number. Guys, listen. Okay, so what will happen? This pivot will be, I mean, 7 will be come to pivot. And what was here? 11 is at the end index currently. So did you see one thing? Did you was, I mean, if you're observing it closely, now 11 is at position where all the left number are lower and all the right side numbers are greater. So 11 is currently is at right position. It is now placed at right position. So 11 is fixed. And this is what called this is what called partition. So the process of moving the pivot number to its starting to its right place is called a partition. And with respect to partition, there are two approaches given by Hore and Lomoto. We are now we are talking about discussing about Hore approach, not Lomoto. Lomoto will cover sometime next because there are approaches we have to just learn one so that we can prepare yourself for the interview. But if someone asks, interviewer asks, so you can say Lomoto approach is also there. And if you know that, that's well, that's that's something, it's a good to have, but right now we are focusing on Hore approach. Now let me reiterate again. So you started moving your start index. You stopped when you found number greater than your pivot number. So in the first case, it was 29. You stopped. As when you stopped rotating or iterating start index, moving start index, you take your end index and you again, you will start moving end index in the left direction from right, and you will stop when you will find number less than the pivot number. So 2 was the number which was less than 11 because 15 and 28 was greater. So as when you find these two, this condition match, then what you swap start index number with the end index number. So what happened, like here we uh, placed 2 and here we swapped 29 and 2 together. Now your condition will go as it is. Now your start index was like 29, it was 2. So 2 was less, 7 was less. So again it came to 29. 29 is greater than 11. And similar as end index, it was on 29. It moved to the next one, 7, which is less than 11. So now this is a situation where end index has crossed start index. If this is the condition, you do not need to swap the number from the start index to end index. Rather, you have to swap the number from pivot index to end index. And this is what we have been doing. So once you do this, once you get into the situation, your pivot number will be placed at a right position, at a right position. Okay. Now this same process will keep on going, will keep on repeating until it sorts all the numbers in a proper order. Now this pivot will be set to 7. Okay. Pivot will be set to 7. And the same story will repeat. Same story will repeat. And I mean, following this approach and methodology, finally your uh, list will be sorted. Now, this was the algorithm. I hope you are clear. Now, let's get into the PyCharm. We'll implement this algorithm, we'll write code. Okay, let me call it quick sort. Quick sort. And what was the number? This was the number. Let me take it element. Let me take this element and let's do it little quickly so that we can finish on time. Otherwise, this video will be little long. So what I will do first here, I will say if name equal to main here, because we are defining the entry point of our program, just to give a little more standard format here. So I will do it here and I will maintain the indentation and I will create one function. I will say quick sort, and here I will pass this element. Now let's create a function, uh, quick sort, and it has created. Now what we have to do is, now first thing what we do, guys, first thing what we do think about partition, right? So I will create one function partition, or let me find partition or create partition. Find partition, I will say find partition, and here I will pass the element. I will pass the element. So guys, let's create another function partition. Now follow the exactly same process what we discussed. Okay, now we got element. We got element. All right, this is the element. Now what we have to do? We have to get the pivot index. What is pivot index? Pivot index is nothing. It's just a zero here. Pivot index what is zero. And what is pivot number? Pivot number. Pivot number is basically element of pivot index. Pivot index. And now also I will say start index is start index. What? Pivot index plus one. Pivot index plus one. What is end index? End index. What is that? End index is length of elements minus one. So this is your end index. So as we discussed, right, initially what we need to do, I think I have changed it, but let me reset it. Let me here somewhere paste it. Paste it. Okay. Okay. No. Maybe I can do here. So initially, what was the thing in end index? So this is what we are doing right now in the code. End index is our last index. Here it is. Start index is our first index, and pivot index is our zeroth index. Right? So this is what we have setted. We have setted. Okay. Now what we need to do? We have to start moving the start index until you find the number greater than the pivot index. Let's do that. So here what I will say, while start start not like this. So we have a pivot index, right? Pivot number. What is pivot number? Yes. Yeah, while start element and start index is less than equal to pivot number. So मैं what I'm saying, मैं क्या बोल रहा हूँ कि अगर if our pivot number, if our element start index is less than pivot number, right? Like now we are checking these numbers. So if this is the case, you just keep on increasing your start index. Keep on increasing your start index. So what we can do, it's like plus one. You have to do plus one. So keep on going, keep on going, keep on going. Similar as this, we have to also check another condition where I have to say elements of end index is greater than pivot number pivot number pivot number. What you need to do, you need to end index, and you have to basically do a minus of one. You have to basically move from right to left. So you have to let's say your right most index is 10, then you have to come left side, so 9 8 7 like that. So we are saying if element of index is greater than pivot number, you keep on going and stop when you find number lesser than your pivot number. So these two things are, you got it. We've found it, right? Now what next we need to do, we have to define one another function, guys, to swap the elements. So I mean, if this condition will come out, then meaning what had happened, like we found those condition where I mean this condition has met, so it will come out of it, right? When it will come out of it, you have to just call a function swap start index and end index, and then you have to call the element here. Now let's create another function called swap, and we'll do a swapping in our regular, I mean, legacy way, like the way we do. What we have to do here is like we have to create a temporary variable. We have to element of start index, sorry, start index, and then we have to update. We need to update our start index element with the end index. So the here we are swapping, right? Like this is the first swap where you say element of start index swap with elements of end index, and your end index will be swapped with the start, which is currently stored in temp. So this is what you did. Swapping is done. Swapping is swapping is done. So this was the one condition. So guys, there was another condition also. What was the another condition? When, and we have to do this in another while loop. We have to do a nesting of while loop. And here we have to start index is end index. So do you remember the another condition where if end index is crossing the when end index is crossing the start index, then you have to come out of this loop and do another swapping, and that swapping you have to done. How you have to done swap, and this time you don't need to pass the start index, you have to do the pivot index you have to pass, and you have to pass end index obviously, and then you have to pass the elements. You get it? One another say, I mean, just to make it safe, one thing that we can do here is start index is not equal to end index, then only you do all of this. Let me check a if condition here just to keep it safe. So this is what the solution is, and now let's run it, guys. So after doing this, we will see that 11 is placed at a right position. Element will be placed at a right position, and before 11 all will be is smaller than 11, and after 11 all will be greater than 11. And this is what we were talking at initially when we talked about partition, basically shifting the pivot number from start to the the place where all the elements before it are smaller and after are greater. Let's run it. Let's see what happens. I think we are not printing anything. We are not printing anything. Let me print. So if I say elements, so what will happen? Let's see. So you see 11 is at a, no, something is going wrong, guys. So 11 is here, but 7 is somehow has come this side. So let's debug it out. Let's debug it out. So this is one thing that we have done. This is good. Is less than pivot number and is greater than pivot number. So basically we are doing this. We are swapping, and in swap we are doing this. This looks fine only. This looks fine. So find partition, quick sort elements. Okay, let's do this. Let's understand this where it's going wrong. So guys, one thing I was missing here when we run the loop, right? This loop. So we have to check one another condition when here before doing swapping, if start index is less than end index, this should be the condition, then only we are gonna call this. Otherwise, what will happen? Uh, there might be a situation where this will take like wrong start or end, and this will do the swapping wrongly. So this condition is very, very important to add here. So if we run it now, so you see like in the output 11 is placed at a right position, and all the numbers after this are greater, and all the numbers before it's like what? Lesser. Okay. Now we cracked the algorithm, we cracked the code. Now this is we have done only for 11. This has to happen for all the elements. This has to happen for all the elements. All the elements, when I say, now you got like, you have to focus only here at a time. Then next, you have to focus here. So we have to call it twice. We have to call it twice. One, I mean, in recursive order, we can implement recursion to run the same solution that we have written twice. Okay. One for the right side of 11, sorry, right side of 11, and one at left side. So let's implement this to support recursion so that we can get our completely sorted. So for that, what we can do here is like we can pass 0 as a start element, and initially, and length element, so -1. This is what we are passing initially to quicksort. And now we have here a quicksort. Here we can get a start index. Let me call it start index, and here end index. Okay. And now here also you have to do same thing. You have to pass in this one. You have to pass in this one. Okay. You have to pass in this one. Then you also need to pass it here. Okay. You got it. And then in this case, what you need to do here is you got the start index. So start index is 0. So start index you can assign to pivot index, and also start index. This is not required because if we even start both pivot and start from the same beginning, from the first element, that is also fine, because that would be either equal, but it won't be greater, right? It would be equal or less. I mean, the first, if we are starting pivot index, pivot number and start number, like we are taking from very start, then the case will be still true. So won't be any problem. So this is not required. And here, sorry, and end is also not required probably because we are passing it from our invoke function invoke, and this all will be still as it is. And now only thing that you have to do here, you have to return here like partition, right? What you need to return? You have to return end index. Return end index. Why you have to return end index? I will let you know. End index. Okay. Now, and I will call it like I mean here I'm calling end index, but here call it pivot index. Pivot index. Okay. You got pivot index. Now you call the okay. You call now quicksort. This is what is recursion now. So let me pivot index, and here I will say quicksort, and here I will call quicksort, and I will call it twice. Let me okay. Once let me think about it. So you have to once start index, and you have to go until pivot index -1. This is the first call. And second call is you have to start from the pivot index +1, and then you have to go until end index. I think this would be working. So did you get it? Like we are calling quicksort twice, and this is like running an iteration. And when you have to run, you have to also note one thing here. You have to do, because this has to happen like until you completely sort the index. So there will be one condition, uh, or loop, I think, not loop. Let me write it a condition. If start index is end index, so you have to keep on doing this. Okay. And what I was saying, like first, the left part, before the 11, so you are passing a start index 0, pivot index is like index of 11 -1. So just before 11, you have to give the index. And this is this is to like traverse at right side from the pivot element, and this is to traverse from left side from the pivot element. So this is what the condition. Let's run it and see what happens. So this is giving a here list out of runs. So you can do one thing here. I think you have to add one condition here. That condition would be start index again is less than let me write, and here less than what, length of what, elements. So this should work fine. Oh wow, great, we have achieved it. We have cracked it, guys. So you see, like, your list is completely sorted. Okay. So I hope the algorithm explanation was clear to you. You got the fundamental, you got the root of algorithm, how it is working, what is the idea behind it, how what is the process of partitioning. I mean, what is the process of partition, and was what Hore approach suggests in terms of partitioning. This solution is based on Hore partition approach. There is another Lumoto. We will not talk about it now. So we followed the approach and this solution is working. I am very happy that it's working. So let's follow the, I mean, this is what we are doing, right? So we are very in a good shape. So guys, I hope you like this video. If you like this video, then my request would be hit the like, share with your friends, circulate with your friends. If you are new to my channel, please subscribe my channel. And if you have any question in understanding the algorithm, you write me in comment. I can connect with you to explain the approach so that you don't have any space for doubt. All right, guys, we can stop here. Bye. See you in the next video. Thank you so much.